Example 16, differentiating functions with other bases. Okay, so part A, I want you to find, or we're going to find y prime, which is the derivative of 2x dx. Alright, so there's two different ways that you can do this problem. You can use the rule, the derivative a to the x power with respect to x equals the natural log of a times a to the x, all right, which is fine. Or you can use the derivative of e to the natural log of a of x, and then the rule here would be e to the natural log of a of x times the natural log of a, which would end up being a to the x natural log of a. I am fine if you just memorize the rule. I'm fine if you use this way. I like to use this way just because this is just sheer memorization. This takes more comprehension, understanding. I retain things longer if I understand where it's coming from. So I usually use that. Okay, so for this one, I'm going to rewrite this as the derivative of e to the natural log of 2 times x with respect to x. And then when I take the derivative of e to the natural log of 2 of x, that's going to be e to the natural log of 2 of x. And then it's the chain rule, so I'm going to have to take the derivative of the exponent, which would be the natural log of 2. And then this would equal 2x times the natural log of 2. 2 to the x power natural log of 2. So that's that one, which is the same as this rule here. Okay, let's look at part B. Part B, same thing here. I'm going to do the derivative of e to the natural log of 2 of 3x with respect to x. When I take the derivative of e to the natural log of 2 times 3x, that's going to be e to the natural log of 2 times 3x. And then again, the chain rule, so I'm going to take the derivative of this, which, alright, so then when we take the derivative of this natural log of 2, 3x, this is going to be the natural log of 2 times 3. Okay, natural log of 2 is a constant, 3x is linear, that's going to become 3. And then remember this part here, this would end up becoming 2 to the 3x times 3 to the natural log of 2. And then this could become 2 to the 3x times the natural log of 2 cubed. And then this would become 2 to the 3x, the natural log of 8. All right, let's look at C. Okay, so for this one, again, you could just use the rule, where the rule states when you take the derivative of log base a of x, or let's do u, with respect to x, that is going to be equal to 1 over the natural log of a u times du dx, which is u prime. That's one way to do it. Or the way that I do it, I like to take the derivative with respect to x, and I rewrite this as log base u over log base a. And then I rewrite this as the derivative of the natural log of u over the natural log of a. And then I think of this as taking the derivative with respect to x of 1 over the natural log of a times the natural log of u. And then when I take the actual derivative, it's going to be 1 over the natural log of a of u prime over u, which is the same thing as this down here. So this 1 over the natural log of a times u times u prime. All right, so let's try this one. So again, I like this method because instead of just memorizing, it's more comprehension, more understanding. I usually remember things better that way. So I'm going to rewrite this as log cosine of x all over log 10. And then I can take the derivative of natural log of cosine of x all over natural log of 10. And then you can think of this as being the derivative with respect to x of a constant, 1 over the natural log of 10 times the natural log of cosine of x. And now I can take the derivative. So the constant is going to be out in front, 1 over the natural log of 10, and then the natural log of cosine of x, this would be the u prime over u. So the derivative of cosine of x is negative sine of x, and u is cosine of x. So this would end up being, the numerator is going to be negative 1 natural log of 10, and then sine of x over cosine x is tangent of x. That would be the answer for that one.